We've been asked to think about two different complex numbers here. z1 equals 5i and z2 equals minus 6 plus 2 root 3i. We're to express them both in their polar form and to then find their product and their quotient. Since I'm just asked to find the product and quotient and not given more instructions, I guess it would be okay to leave them either in rectangular or polar form. I'm going to do both because I really want to think about these in polar form, and I think it would be good practice for us to convert them back to rectangular form. But to start off, I need to write both numbers down in their polar form. So if I think about z1, 5i is just a purely imaginary number there on the y-axis. So if I think about z1, I know it's 5 units away from the origin, and then the angle is pi halves. So writing that down in its polar form doesn't require anything too sophisticated. My next complex number, I go over to minus 6 and then up to 2 times the square root of 3, which is about 3.4. So if that was another 6 and something like this, right? And I think I can even imagine what angle that is, but I shouldn't leave things like that up to my imagination. So when thinking about z2, r is going to equal the square root of a squared, 36, times b squared. Well, let's see, that's going to be a 4 times 3 is 12. That's the square root of 48, which we should say is the same as 4 times the square root of 3. Thinking about that 48 as a 16 times 3, square root of 16 is 4. So I found my r value for z2. And then I know that will be multiplied by cosine plus I sine, and I'm just looking for the angle to plug in both. All right, tangent of theta here in z2 would be equal to 2 root 3 over a minus 6. So minus 2 root 3 over 6 is minus root 3 over 3. Well, if I thought about an inverse tangent, I'd get an angle down here in quadrant 4 of minus pi 6, which is really just telling me that reference angle is pi 6, and I see that angle as 5 pi over 6. All right, so check. I've gotten z1 and z2 in polar form, and I know it's easy to multiply complex numbers in their polar form. Because what I do is I multiply the radii, and so I get 20 root 3 here, and I add the angles, I add the arguments. So let's see, cosine of some angle plus I sine of that same angle, I need to add pi halves and 5 pi over 6. Well, that would be 8 pi over 6, right? Because I think about that pi halves as being equal to 3 pi over 6. So add them together, I get 8 pi over 6, but I'm going to reduce my fraction, of course, to 4 pi over 3. All right, well, I should be able to evaluate my trig functions and get this back into a standard form. So I need to know what the cosine of 4 pi over 3 is. It's certainly a negative number, and in fact, it's going to be minus 1/2, plus I sine of 4 pi over 3. Well, thinking about where 4 pi over 3 is, again, a negative value, and that's going to be a minus root 3 over 2. And now I get to distribute. So 20 divided by 2 there, I'm going to get a minus 10 root 3 as the real part, and then minus, let's see, 20 divided by 2 is 10, and root 3 times 3 would be 3, so minus 30i. And so now I've multiplied those two complex numbers, and I've written it down in this rectangular form, and I suppose there's any number of ways to also kind of think about that. I could just think about distributing through this one, and I don't think that would be that hard, and it's a good way of confirming my answer here. All right, so now I've also been asked to divide those two complex numbers, so z1 over z2. And I know what I do is I divide the radii, I divide those r values, so I'm going to have a 5 over 4 root 3. Cosine plus I sine of an angle that this time I find by subtracting my two angles. And so I now have pi halves minus 5 pi 6, which would give me a minus 2 pi over 6 or a minus pi thirds. Now, when dealing with a complex number in their polar form, that final angle is supposed to be on that first full revolution. So now I'm thinking about an angle that's coterminal with minus pi thirds. And so instead of minus pi thirds, my final answer is going to have a 5 pi over 3 in it. All right, and in my final answer, I want to evaluate this trig functions and then write this down in its rectangular form. So let's see. What I know so far is that z1 over z2 is equal to 5 over 4 root 3 times the cosine of 5 pi over 3 plus I sine of 5 pi over 3. So now I'm left to evaluate my trig functions and then just do a little distributing. And so I still have that 5 over 4 root 3 here. And now I need to know the cosine of 5 pi thirds, which is 1/2, plus I times the sine of 5 pi thirds, which is minus root 3 over 2. All right, I have a little thinking to do here as I distribute. Here I will get 5 over 8 root 3 plus I, and my root 3's actually cancel here, and I would just get a negative 5/8. All right, and some people might want me to rationalize my denominator on this first one, so that'd be 5 root 3 over 24 minus 5/8 I, though I think that is just as good of a final answer. But that's it for now.